Hello students. Our second video in this section is about ethics, conducting statistical studies in an ethical way. And so we're going to talk about some ethical case studies, some kind of examples of ways that people have done this poorly, and then also about ways that you can do statistics in an ethical way. I just want to start off by talking about a pretty well-known study which was conducted unethically, and talk about some of the kind of things that this person did incorrectly, and then talk about some of the things that can go wrong and some of the things you have to think about when you're setting up a study. So in 1998, a British scientist named Andrew Wakefield, who's fairly famous for unethical science, published a study in The Lancet, which is a British medical journal, linking autism to the measles, mumps, and rubella vaccine, the MMR vaccine. And so basically what he said was that if you get this vaccine, you'll get autism. And he had reasons for what he claimed had done it. He claimed he had done a study that showed this. It turns out that much of the data in the study was faked. He had adjusted the data to fit the conclusion that he wanted, and that the reason he was doing this was because he had set up a company that was going to sell autism tests to test whether your child was at risk of autism if they had gotten the MMR vaccine. None of it was really backed up by good science. The study's been debunked many times, and Wakefield has lost his license to practice medicine. I think he's been threatened with criminal charges. But the damage has already been done. So you probably know that there have been measles epidemics. Mumps has come back in the U.S., and people have died because this man conducted research in an unethical way. And so the idea here is that, especially with medical research, but any kind of research, if you conduct it in an unethical way, you can convince people that something is true that isn't necessarily, and that can cause a lot of damage. Similarly, what we're seeing right now with the COVID-19 crisis, there's a lot of kind of rumors going around. You'll hear things about people should take ibuprofen, people shouldn't take ibuprofen. You'll hear about chloroquine, which is a drug which some people have claimed is effective in fighting COVID-19. And honestly, the reality is we just don't know if any of this is true yet. So anybody who claims that it's true is really being unethical in how they communicate scientific data. And that's what we want to focus on today. Okay? So I want to talk about a few kind of topics in experimental ethics, starting off with conflict of interest. We talked about this a little bit the other day. So conflict of interest is when you have something to gain from a particular scientific result being true. Wakefield stood to profit quite a bit if he linked MMR vaccines to autism. So having this conflict of interest, while it doesn't necessarily make the science bad, it's something that people should know about, because they should be able to say, okay, yes, this science, this research was conducted by somebody who stood to profit from it. Does that make me believe them any less? Should I look at their experimental design more carefully, etc.? So disclosing conflicts of interest is always very important. Not having conflicts of interest is even better. But honestly, we're human. Everybody has reasons why they're interested in studying something. So an autism researcher whose child had autism, for example, might have a conflict of interest, right? They have an interest in, learning more about autism, but it doesn't necessarily make their science bad, right? Because they're looking for the best results for their child. Something else that can come up in experimental design, this is something that people do, they can do unconsciously even, is called cherry picking. So cherry picking is when you only talk about data or look at data that fits the result that you want to believe. So for example, if you were trying to show that caffeine intake improves student test scores, you might say, oh, well, yeah, there were these students who did worse, but it was because they were tired. I'm not going to look at that data. I'm just going to look at this data that kind of supports what I'm interested in. So cherry picking can be very dangerous. This can also be kind of like looking at a lot of different variables and then saying, oh, this one shows a link. So there's a cause here. That's also a kind of cherry picking when you're just looking at the data that agrees with what you are actually interested in. Stopping a study prematurely. So say, for example, you're studying a drug and how well it causes, if it helps people recover from a disease, and say those people start to get better, but then it kind of levels off and it doesn't benefit them as much after a few weeks, right? So if you wanted to show that this drug works, you might stop the study after a few weeks and say, oh, look, they're getting better, right? But that ignores the fact that then they get worse after that, okay? So both cherry picking and stopping a study prematurely can be prevented by very clearly stating how you're going to conduct a study before you start it. Okay, so the idea of good scientific research is at the outset you say, I'm going to do this and this and this. This is the question I'm trying to answer. This is how I'm going to answer it. And this is how I'm going to analyze my results. And you do all of that at the beginning before you even start, and then you stick to it. Okay? And that stops you from running into these situations with cherry picking or stopping a study prematurely. And a lot of scientific research, for example, medical research, is done this way. It has to be done this way. Before you start, they'll ask you to set up the entire plan. You have to submit it to either an institution like the FDA or possibly a body at your own research institution, something called an institutional review board, anything like that. And they say, okay, is this a good way to study this? Are they avoiding some of these ethical concerns? Another one, and this is what we're going to talk quite a bit about because this is kind of a mathematical topic, communicating data in a misleading way. So the next video is going to be me going through a PowerPoint talking about misleading graphs and talking about kind of how you can avoid misleading people with quantitative data. So that's a big one. We'll talk quite a bit about that. Just because you've gotten data doesn't mean that you're going to present it in the most clear way. And sometimes you can present it in a way that is intentionally misleading, which is even worse. The next thing on my list here is informed consent. So this is a principle that anybody participating in a scientific study should always give informed consent, which is to say, you know what consent is, right? They have to agree that they're willing to do this. But then even more so in a scientific study, we're looking for informed consent. And that means that they need to know what the risks are, what possibly bad could happen to them, what good could happen to them. They need to understand kind of what they're agreeing to. So, for example, if you're giving somebody a treatment for a disease, and they could either be getting the pill or being in a placebo group where they don't get anything, you have to tell them that this is a possibility. You're agreeing you might be getting medicine that will help your disease get better, but you might also be getting a placebo, which won't help your disease get better, right? And if somebody is in a situation where they're, for example, dying of that disease, they wouldn't necessarily agree to that. So studies for fatal diseases tend to be conducted in a different way, where, for example, if you're studying, for example, cancer, you might treat some with both a drug that already is known to help destroy the cancer and the experimental drug, or you might treat the placebo group with just the drug that's already known to fight cancer, and then see are the results better for the people who are getting both, right? So you have to design your study in a way that isn't going to harm people as much as you can. That's the idea of informed consent, and they need to know that. And then the other thing is that people have a right to privacy. So you're not necessarily going to publish their information. And this is just a general medical right. Those of you who are studying nursing know about things like HIPAA, which is the Health Insurance Patient Protection Act, I think, something like that, which protects your medical data. You can't share somebody's medical data. And privacy rights in experimental design are similar. You can't say that somebody's participating in this study because that might affect them in some way that you shouldn't. So people who are participating in these studies have a right to privacy. So before we finish, one last case study. This is another one that kind of gets into informed consent and privacy. This was a case in Baltimore. Baltimore is fairly famous. which is the case of a woman named Henrietta Lacks. So Henrietta Lacks was a cancer patient at Johns Hopkins University in 1951. She was dying of cancer. She passed away. Johns Hopkins kept her some cells from her body because they discovered that these cells would reproduce outside of the body and that they could be used for medical research. And so when they did this, Miss Lacks, who was a young African American woman, they didn't tell her that they were doing it. They didn't tell her family. And it all came out very recently. There was a film about it a few years ago. It wasn't until the 2000s that the family found out that they'd kept part of their mother's remains. And Johns Hopkins had been selling access to these cells, but these cells from her body had been used to save countless lives, to create kind of life-saving treatments, to do medical research that saves a lot of people. And so you start to get into these complicated ethical questions. A lot of the times when doctors do things that are unethical, so saving her cells without her family's knowledge, without her knowledge, violates informed consent, it violates privacy. It was unethical to do it. It also saved a lot of lives. And so these are the reasons why people get into these complicated ethical situations, is because they really do want to help people, and so they may make medical lapses. Of course, there's a lot also other that goes into Miss Lack's case. Part of the reason that they kept it without asking the family was because she was black. Baltimore was, still is in a lot of ways, had a huge race problem, and the white doctors didn't necessarily treat her as well because she was African American. There are a lot of things that go into this and people's biases, but the ethical questions of the study, it's very important that we conduct research in an ethical way, and because it leads to better science and it helps people more, and it doesn't harm people. So the next video that I'm going to show you talks about communicating mathematics in a misleading way using graphs. I'll be narrating a PowerPoint and showing you some examples of misleading ways to communicate data.